Alright, in this video we're going over rational exponents. So what is rational exponents? It's simply an exponent. That's a fraction. Alright, simplifying expressions with rational exponents. Now, if you look at the blue box here, it says, in general, the nth root of x equals x raised to 1 over n for any positive integer n. Like the radical form, the exponent form indicates the principal root. So if you notice here, the square root of 36, in here would be a 2, and as you can see, they took 36 and raised it to the 1/2. So what you can do is you can take n, alright, take your number, and you can raise it to 1 divided by n, and these two are mathematically equivalent. Same thing with this. The cubed root of 64 is the same thing as 64 raised to the 1/3 power. And then the same thing here. The 4th root of 16 is equal to 16 raised to the 1/4 power. Alright, so you simply take the index and do 1 divided by that number, and then you can use that as an exponent for what you're trying to take the root of. So let's look at one. So it says, what is the simplified form of each expression? Well, we know that 216 raised to the 1/3 power is the same thing as the cubed root of 216. Right? And if you take the cubed root of 216, you will find out that that equals 6. So 216 to the 1/3 power equals 6. Alright. Now, letter B here we can do one of two ways. The first way is we can simply use our properties of exponents that we know, and when you multiply numbers with exponents, you simply add the exponents. So this is going to be 7 raised to the 1/2 plus 1/2, which is simply 7 to the 1st, which is simply 7. Or you could convert these into radicals and make it the square root of 7 times the square root of 7, which of course when you multiply a radical by itself, the radicals cancel out and you're just left with the number underneath. Okay? Now this one here, we can also do one of two ways. We could make this the 4th root of 5 times the 4th root of 125. Alright, well, 4th root of 5 times 4th root, well, we know that 125 is simply 5 cubed, okay? Because 5 times 5 is 25, times another 5 is 125. So we can combine this way to get the 4th root of 5 to the 4th. The 4th root and the exponent cancel out, leaving you just 5. Or what you could do with this one is, if you recognize that 125 is simply 5 cubed, you can write this as 5 to the 3/4 power. Okay? Because the 3 here means you're raising the 5 to the 3, and then the 4 on the bottom means you're taking the 4th root of that. So this here is equivalent to writing the 4th root of 5 cubed. Alright, this is simply the 4th root of 5 cubed. And now, of course, you can apply your rules of exponents. So this equals 5 raised to the 4 over 4. It's an equal sign, not a negative sign. Well, 4 over 4 is 1, and it's simply 5 to the 1st, which is 5. Alright. So not too bad. You can simply take your fraction. If you have a fraction, the top number will be the exponent. The bottom number will be the root, okay, or the index for your radical sign. Alright? This is what I just went over. It says if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then a to the 1 over n simply equals the nth root of a, and a raised to the m over n is simply the nth root of a raised to the m, which of course also equals the nth root of a, that quantity, raised to the m. And of course, if a is negative, if m is negative, a cannot equal 0. Alright? So make sure you write that down, make sure you remember that. All that simply says is if you have a fractional exponent, the number in the top becomes the exponent, the number in the bottom becomes the root. All right. So, converting between exponential and radical forms. So, what are x to the 3/7 and y to the negative 3.5 in radical form? Well, again, we know that the 3 is an exponent, so we're going to have x cubed, and the 7 will be the root. So it's going to be the 7th root of x cubed, which of course can also be written as the 7th root of x quantity cubed. All right. Either one either one of those is correct. All right, either one of those is correct. Now with this one, what we need to do here is convert this into a fraction. We know it's going to be negative, but we want to convert it into a fraction. So 3.5, well, that's simply 7 over 2, because 7 divided by 2 is 3.5. So you want to take, if you have decimals, you want to take them and convert them into fractions. All right, you want to take them and convert them into fractions. So now this is simply going to equal 1 over y to the 7/2, which is simply going to equal 1 over the square root of y to the 7th. And of course, you can break this up. It's going to be 1 over the square root of y to the 6th times y. And of course, since this is an index of 2, 6 divided by 2 is 3. So this will be 1 over y cubed times the square root of y. And of course, now we have to rationalize our denominator. Easiest way to do that is multiply by the radical in the bottom. So 1 times the square root of y is just the square root of y. The square root of y times the square root of y, the radicals cancel out, leaving you with y. So it's going to be y cubed times y, which of course is the square root of y over y to the 4th. And that is your final answer. All right. Don't forget, you need to make sure that you rationalize your denominator. And again, the easiest way to rationalize your denominator is simply multiply the top and bottom by the radical in the bottom. All right, I want you to take a moment and see if you can do letter B here. What are the square root of a to the 5th and the 5th root of b quantity cubed in exponential form? So pause the video and see if you can do those. Convert them into exponential form. All right, well this one here, we know we have the cubed root, so we're going to have the square root. So we know that the bottom of our fraction is going to be 2, and since it's a to the 5th, the top of our fraction is going to be 5. So we have a raised to the 5/2. Hopefully you got that. Now here, we know since we have a 5 for the root and a 3 for the exponent, this is simply going to be b raised to the 3/5 power. All right, it is simply going to be b raised to the 3/5 power. Okay? So again, when you're converting from radical form to exponential form, exponents go in the numerator of the fraction, and roots go in the denominator of the fraction. And likewise, if you're going the other way, if you're going from exponential form to radical form, the numerator becomes the exponent, and the denominator becomes the index. All right? And don't forget that negatives mean you just simply put them in the bottom, or you reverse the side of the fraction bar they're on. This one's in the top, so therefore it'd go to the bottom. It doesn't mean you're going to have a negative number as an answer. It just means that it's on the wrong side of the fraction bar. Okay? All right, here's a chart with your properties of exponents for kind of a refresher. We know that a raised to the m times a raised to the n is simply a raised to the m plus n. Here's a quick example of that. And a to the m raised to the n is simply a to the mn. So when you multiply numbers with exponents, you add the exponents. When you raise an exponent to an exponent like they're doing here, you multiply the exponents. And then, of course, exponents use the distributive property. You can distribute the m to the b and to the a. So ab quantity raised to the m is a to the m times b to the m. All right, here's a to the negative m. Again, like I said, this is technically over 1. So since it's a negative exponent, it just means it's on the wrong side of the fraction bar. So you change sides with it. So from the top goes to the bottom, your exponent becomes positive. So a to the negative m is simply 1 over a to the m. When you divide numbers with exponents, you simply subtract the exponent. Now, you always subtract the top from the bottom. If it comes out positive, you're good. It stays in the top. If the exponent comes out negative, then you would just go back up to here and change the side of the fraction bar. All right, and this one is really no different than the multiplication problem. You simply distribute the m to the a and distribute the m to the b. Okay? Like I said, this chart was really just a refresher. This is things you should already know. And also remember, denominators cannot equal 0. Okay? All right. Combining radical expressions. So what is the 4th root of x cubed divided by the 8th root of x squared in the simplest form? Well, this is an easier problem than it sounds. The first thing I would do is change these to exponential form. So we're going to have x raised to the 3/4 divided by x raised to the 2 over 8. All right, so this is x to the 3/4, and then 2 over 8 will reduce down to 1 over 4, like that. Now remember, when you're dividing numbers with exponents, you simply subtract the exponents. So this is going to be x raised to the 3/4 minus 1/4, which is simply 2/4, which is simply 1/2. So this whole thing simply equals x to the 1/2, which is the square root of x. All right, not too bad. X to the 1/2. Remember, you just simply, when you're dividing numbers with exponents, you simply subtract the top from the bottom. If you can simplify them, go ahead and simplify them first. But just keep in mind that you will need like denominators. So if one of them is, if you can simplify one of them, but they both have the same denominator, don't simplify it first. Go ahead and do the subtraction and see if you can simplify it later. Here, however, since 2/8 and 3/4, the denominators weren't the same, so I did go ahead and simplify it. And in the process of simplifying it, I got the same denominator. All right, so simplifying numbers with radical exponents, rational exponents. What is each number in simplest form? Well, we have 16 to the negative 2.5, so we need to take that and convert it into a fraction. 2.5 as a fraction is 5/2. All right, so now let's try to make this a little simpler. All right, well, we know that that 16 is simply 2 to the 4th. So this is going to be 2 to the 4th raised to the negative 5/2. All right, well, if we multiply these together, we know that this is going to go to a 2, that's going to go to a 1, so this is simply going to equal 2 to the negative 10. And I wrote 1/10. This is simply going to be 2 to the negative 10. Well, we know that is simply 1 over 2 to the 10th, which is 1 over 1024. All right. Letter B, negative 32 to the 4/5 power. I want you to go ahead and try this one. So pause the video and see if you can figure this one out. All right. Again, we can try to simplify this down a little bit. We know this is simply going to be negative 2 to the 5th power. All right, negative 2 to the 5th power. And that's going to be raised to the 4/5 power. Of course, when you can multiply the exponents. We know that this 5 and this 5 is going to cancel out. So this is simply going to be negative 2 to the 4th which is simply positive 16. Alright, simply positive 16. So, as you can see here, trying to simplify down the numbers you're given first will actually give you less work in the end and keep your numbers smaller. Like this one here, this is the fifth root of negative 34 to the fourth. Well, who wants to take negative 34 and raise it to the fourth power? I know I don't. Okay, I know I don't. So let's go ahead and try to break this down. Well, this is simply negative 2 to the fifth power raised to the 4/5 power. And then, of course, the 5's cancel out, leaving you just negative 2 to the fourth, which is just 16. So try to simplify your numbers first, all right? Because you might be able to cancel some stuff out with your exponents to make the problem a lot easier in the end. All right, I'm only going to do one of these because this video is getting kind of long. If you remember, we have all of this raised to the 2/3. Well, what you can do is you can distribute this exponent into everything. All right, so this is negative 8 raised to the 2/3, x raised to the 2/3, and x times y to the 1/2 raised to the 2/3. All right. The reason I did that is because that'll cancel with that, leaving you just the 3. Okay. So this is negative 8 raised to the 2/3, x raised to the 2/3, and xy raised to the 1/3 power. Okay. So now again, let's try to simplify this down. Well, this is simply negative 8. I'm sorry, it's negative 2 cubed raised to the 2/3 power. Again, the 3's there will cancel out, so this is simply negative 2 squared, which is 4. And then here we have times x to the 2/3, and this we can distribute this through, so it's x to the 1/3, y to the 1/3. There's the bell, so I'm going to hurry up and finish. Here you simply add your exponents because we're multiplying them together. 2/3 and 1/3 is 3/3. 3/3 reduces to an exponent of 1, so that's just 4x. And of course, now we're left with y to the 1/3. Well, that is simply the cubed root of y. All right, pause the video, see if you can get this one. Your final answer should come out to be y to the 6th over 8. All right, so feel free to watch this video as many times as you need to. Make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.